In addition to talking about the interior angles of a polygon, we can also talk about the exterior angles as well. So as a reminder, what an exterior angle is if we extended one of the sides, for instance, if I extend this side right here, I would get this exterior angle 3. So you can do that around all of the different sides of a polygon. Now the nice thing is, no matter how many different sides there are, those will always end up adding to be 360 degrees. Okay, so 4-sided figure, 5-sided figure, if it's a 70-sided figure, they would still add up to be 360 degrees. So we can use that information as well, and we got to keep in mind that those things are going to end up forming a linear pair, the interior angle and the exterior angle. So we have that relationship as well, so which means they're supplementary. So if we add them together, we get 180 degrees. For instance, if I knew that interior angle right here, and I added that with angle 3, the exterior angle, those would equal 180. So we can kind of use that as a shortcut for some of the other problems that we're going to come across. And I'll show you two different ways in which you can find those. For these next two examples, we're considering the term regular hexagon and then regular pentagon. What that means is that all the sides are going to be congruent, all the angles are going to be congruent. So it's going to have all 5 angles are the same, all 5 sides are the same for this one, and all 6 angles and all 6 sides are the same. Alright, so again, this is going to be n is equal to 6. So if I wanted to figure out the total number of degrees internally in that hexagon, what I would have to do is I would take my 6 minus 2, and I would multiply that by 180. Alright, which ends up turning out to be 4 times 180, and we know that that will give us 720 degrees. Okay, so there's 720 total degrees interior for that regular hexagon. Now, if it's a regular hexagon, like I mentioned, that means everything is going to be the same. So if I take this 720 and I divide it by the 6 different angles that are going to be inside, that's going to tell me the measure for each of those angles. So we're going to take 720 and we're going to divide it by 6. So each of the interior angles in this case are going to end up being 120 degrees. Okay, now we can also consider two different ways. We know that based on what we saw right here, the interior and the exterior make a linear pair, meaning they add to be 180 degrees. So if I take 180 and I subtract my interior, that's going to give me my exterior. So that's one way to find this. So I'll take my 180, okay, because that's what they're going to add up to. They make a linear pair. I'll subtract that, 120. And that tells me that that exterior angle will be 60 degrees. All right, that's one way to approach the problem. Another way to approach the problem would be to take a look and say that, okay, we have 360 total exterior degrees. All right, if I divide that 6 ways, because I will have 6 exterior angles, we can just take 360 and divide it by 6. And that also will equal 60 degrees. So it's two different ways to do the same problem. So you can take either route for those, so one or the other. Take a look at another example. So like I said, for this one is a pentagon, which is a 5-sided figure. And regular, meaning it has all 5 of the sides are going to be the same in length, all 5 of the angles will be the same in measure. So n is equal to 5 in this case. Alright, let's do the same thing we did before. Let's figure out how many total interior degrees are going to be in there for that pentagon. So I would take my equation, which would be n minus 2, so 5 minus 2 times 180. Alright, once we simplify it, we find that we get 3 times 180, which gives us a total of 540 degrees. So 540 degrees would be the sum of the interior angles on this pentagon. Again, since it's regular, we're just going to take that total amount and we're going to divide it 5 ways because there's 5 angles in a pentagon. So 540 divided by 5 would end up equaling 108 degrees. Alright, so again for the exterior angles, so just like you can see right here, this is a pentagon. It's not a regular pentagon because the angles are different, the sides are different, but you can see that it has those 5 exterior angles. So what I can do is I can either take the 360 and divide it by 5, or I can just take 180 and subtract this because again, they form a linear pair, they're supplementary. So once again, I'll show you both routes. We could just say since they make a linear pair, the interior and the exterior, I can take 180 and subtract 108. And I find that I'm going to get a 72 degree exterior angle. So every one on that will be 72 degrees since it's regular. Alright, the other approach as well, so the OR version, would be to take my 360, because I know that is the sum of exterior angles for any polygon, 360 degrees, and I'm going to divide it 5 ways, because there will be 5 exterior angles that go along with that pentagon. So that also, if you were to type that in your calculator, do the division, you would also get 72 degrees. All right, either route is acceptable, doesn't matter which one you take. Just know that there's 2 routes to find it. The one thing you do need to remember, though, is the interior and the exterior do form a linear pair. So interior and exterior form a linear pair. So that is worth noting.